Let's settle this once and for all. Advanced aliens did not travel across the universe just to stack heavy rocks in the desert. Humans built the pyramids. Believing in science fiction is easy, but the real truth is pure engineering success. Ancient builders used river channels to float giant blocks. They used wet sand to slide heavy stones. They used water trenches to level the ground. And they used internal ramps to lift massive rocks into the sky. Let's break down the real construction, step by step. First of all, if a direct waterway had existed right next to the pyramid site, it would have reduced the required human labor by more than 80%. Dragging massive stone blocks across burning desert sand requires impossible physical effort, but floating that exact same weight over water completely changes the equation. And guess what? That exact water highway actually existed. Modern radar satellites scanning beneath the deep desert sands recently revealed a hidden geological wonder. Thousands of years ago, a massive lost branch of the Nile River, known as the Al-Ramat branch, flowed directly alongside the Giza Plateau, right at the doorstep of the construction site. This was the exact missing piece of the puzzle. For decades, researchers could not explain how millions of tons of stone moved across dry desert without modern machinery, which led people to invent wild theories about aliens. Without knowing this waterway existed, dragging those massive blocks across miles of scorching sand truly seemed impossible. Ancient builders did not just rely on the natural river, they actively engineered it. They carved deep, artificial canals, large water basins, and stone docking harbors connected to this lost branch. Massive wooden cargo boats carrying giant stone blocks could float directly from distant quarries across Egypt and dock right at the base of the plateau, turning an impossible desert journey into a smooth delivery system. Now that the biggest transportation problem was solved, the builders could focus on their next massive challenge: preparing the ground. Before stacking a single heavy stone, they had to turn a huge, uneven rocky hill into a completely flat platform. If the base was tilted even by a tiny fraction, the entire structure would lean and collapse as it grew higher. To make the rocky floor perfectly flat without lasers or modern tools, they used a brilliant trick with water. Workers carved a connected grid of shallow trenches into the bedrock and poured water into them. Because water always creates a completely flat surface on its own, they marked the water line on the trench walls, drained the water, and simply chipped away all the high rocks sticking above the marks. In just a few simple steps, they had a massive, perfectly flat stone foundation. With a flat foundation ready, the builders faced another precision challenge. The four sides of the Great Pyramid align almost perfectly with true north, south, east, and west. Yet ancient builders had no magnetic compasses, laser levels, or satellite navigation. They solved this puzzle using basic geometry and the sun. A surveyor planted a tall vertical pole in the center of a flat circle drawn on the ground. As the sun moved across the sky, the shadow of the pole touched the edge of the circle in the morning and again in the afternoon. Connecting those 2 points created a perfect east-to-west line. To double-check their accuracy, they looked up at the night sky. By watching 2 specific stars rotate around the celestial pole and dropping a simple weighted string when they lined up, builders found true north with astonishing precision. The construction site was now perfectly flat and pointed in the exact right direction. Now, the workforce had to cut millions of massive stone blocks from the earth. But this creates another famous historical puzzle. Ancient Egyptians did not have hard iron or steel tools. They only had soft copper, wood, and stones. So how do you carve giant blocks out of solid rock? For limestone, they used the natural expanding power of wood. Workers chiseled small slots into the rock face and hammered dry wooden wedges deep into the cracks. Then they poured water over the wood. As the dry wood absorbed the liquid, it swelled with massive pressure, cleanly snapping huge stone blocks free from the quarry wall. For ultra-hard granite, they used an even smarter physical trick. Soft copper saws alone could never cut through hard granite, so workers poured sharp quartz sand under the blades. As the metal saw moved back and forth, the hard quartz crystals trapped underneath acted like microscopic teeth, grinding smoothly through the solid rock. Once the stones were cut from the quarries, workers loaded these massive blocks onto heavy wooden sledges. But pulling thousands of pounds across soft desert sand creates a brutal physical obstacle. The heavy front of a sledge immediately digs deep into dry sand, creating a miniature sand dune in front of it that grinds everything to a complete halt. Ancient builders solved this with a brilliant understanding of soil mechanics and surface tension. A worker stood on the front of the moving sledge, pouring small amounts of water directly onto the dry sand. When sand grains get slightly damp, water molecules create tiny microscopic bridges between each grain, locking them tightly together. This simple trick turned soft, sinking sand into a stiff, smooth highway. It stopped the sand from building up in front of the runners and cut pulling friction in half. Instead of 50 men struggling to budge a single stone, 20 workers could glide that same heavy block across the ground with relative ease. Now, millions of stone blocks were sitting at the base of the platform, ready to be stacked. This brings us to the biggest engineering mystery of all. How did they lift heavy stones over 400 feet into the air without modern construction cranes? For a very long time, the most popular theory was a giant straight ramp built out of dirt and rubble. Historians believed workers simply dragged stones up this massive external slope as the pyramid grew taller. But modern civil engineers quickly pointed out a fatal physics flaw in this idea. To maintain a gentle slope that humans could actually pull heavy weight up, a straight ramp reaching the summit would need to be over a mile long. Such a ramp would require more material than the entire pyramid itself and would violently collapse under its own massive weight. A giant straight ramp was a complete engineering impossibility. If building a massive ramp on the outside of the pyramid is impossible, where do you put it? The answer is brilliantly simple. You put the ramp inside the building, just like a modern multi-story parking garage. The workers started the base with simple, short dirt ramps on the outside. But once the pyramid reached about 1/3 of its total height, they changed their strategy and began building a gently sloping, hollow tunnel directly behind the outer stone walls, spiraling upward layer by layer. But this creates an obvious problem that anyone would notice. How do you pull a giant 2-ton stone sled around a sharp 90-degree corner inside a narrow hallway? You cannot simply bend a massive block of solid rock around a tight corner. Ancient builders solved this by leaving the 4 corners of the pyramid completely open, like little balconies. When a stone sled arrived at an open corner platform, workers used simple wooden levers to pivot the entire sled 90 degrees, pointing it straight down the next straight tunnel to keep moving upward. To make pulling the heaviest stones even easier, they used a clever counterweight system. Inside the pyramid, they used a massive sloping hallway as a heavy-duty trolley chute, allowing falling weights to slide downward and pull rising stones upward with far less human muscle. Modern science proved this hidden design was real. High-tech thermal cameras and density scans of the Great Pyramid revealed faint spiral tunnel patterns winding through the solid stone, proving the builders simply sealed their secret roadway inside the monument when the job was finished. Moving standard 2-ton blocks was impressive, but deep inside the pyramid lies a far more dangerous engineering challenge. Builders had to construct a large hollow room, known as the King's Chamber, directly underneath millions of tons of crushing solid rock. Ordinary limestone was too soft for this task and would crack under extreme tension. So builders traveled over 500 miles south to Aswan, quarrying massive blocks of ultra-hard red granite and floating them down the Nile River on giant cargo barges. These granite beams were absolute monsters, with several weighing over 50 tons each. Raising these colossal stones dozens of levels high into the center of the pyramid required steady counterweights, massive wooden sleds, and absolute coordination across the entire workforce. However, putting them in place created a terrifying physics problem. If you simply place a flat stone ceiling underneath a massive artificial mountain, the immense downward gravity will eventually snap even solid granite right down the middle. To prevent a catastrophic cave-in, ancient engineers invented a brilliant weight distribution design. Directly above the flat ceiling of the room, they built 5 hidden empty compartments stacked on top of each other, topped by a massive triangular pointed roof made of giant limestone blocks. This pointed roof acted like a giant stone shield. Instead of letting millions of tons press straight down onto the flat ceiling, the triangular slope split the crushing downward force and redirected the pressure safely outward into the thick surrounding walls, keeping the room safe for thousands of use. Solving these immense structural challenges and lifting 50-ton granite beams required sheer physical effort. But machines do not stack stones on their own. Humans do. For decades, popular culture claimed millions of chained slaves were whipped across the desert sand to build this monument. Modern archaeology, however, proves this dark legend is completely false. Right beside the Giza construction site, archaeologists uncovered a massive planned city built entirely for the workforce. This was not a miserable open-air prison camp, but an advanced residential town featuring organized housing, clean water systems, large communal dining halls, and industrial bakeries capable of supporting over 20,000 permanent and seasonal workers. To keep thousands of men hauling heavy stones every day, the project required an enormous supply of high-energy fuel. Excavations around the worker village revealed massive animal bone deposits, showing that the builders ate thousands of pounds of prime beef, sheep, and fresh fish daily, alongside nutrient-packed grain bread. They were fed better than almost anyone else in the kingdom. Even more fascinating is the elite healthcare provided to the workers right on site. Skeletal remains found in nearby tombs show carefully set broken bones, healed skull injuries, and even evidence of delicate surgical procedures. These men were treated as valued national specialists, receiving expert medical attention and paid resting periods whenever accidents occurred. Managing such a massive workforce demanded extraordinary managerial talent. Engineers divided the workers into competing units with colorful team names, which the builders proudly carved onto quarry walls. Through 3-month rotating shifts, everyday citizens joined the project during annual river flood seasons without ever abandoning their local family farms. Raising the Great Pyramid was therefore not a story of cruel slave labor, but the greatest logistical masterpiece of the ancient world. Feeding, sheltering, and motivating tens of thousands of skilled citizens over 2 decades proved that brilliant human coordination was just as powerful as stone, water, and clever physics. After more than 20 years of non-stop work, the organized workforce finally brought the core structure of the Great Pyramid to its maximum height. But the monument we see today, with its weathered brown stone steps, looks nothing like the finished masterpiece that stood in the desert thousands of years ago. To complete the Great Pyramid, builders wrapped the entire exterior in an outer shell of pure white Tora limestone. Each massive casing block was cut at a precise angle of 51 degrees and fitted so tightly against the next stone that you could not even slide a single thin blade between the seams. The crowning moment began at the very top. Workers hauled the capstone, known as the pyramidion, to the peak, likely coated in a gleaming layer of gold and silver. From there, stonemasons worked their way downward, polishing the white blocks to a mirror shine, while dismantling leftover ramps as they descended. When completed, the Great Pyramid transformed into a colossal desert mirror. Under the intense Egyptian sun, the smooth white limestone reflected bright sunlight across the entire valley, making the giant monument visible from dozens of miles away, like a shining beacon rising out of the sand. Over the centuries, powerful earthquakes shook the casing blocks loose, and later rulers stripped away most of the polished white stones to build palaces and walls in Cairo, eventually leaving behind the rough stone skeleton we see standing today. So, what do you think? Did thousands of brilliant humans master engineering and physics to build this wonder? Or did aliens really fly across the entire universe just to stack rocks in the desert?